We're going to talk about parabolas in the context of conic sections. A conic section is formed when a right circular cone, you can see there in the blue, with two parts, the upper and the lower part, called napes, is intersected by a plane in 3D, which we can see in the transparent grey there, and the curve of intersection, which we can see right there in the red, is a parabola. So if we rotate this around, we can see the plane intersecting our cone here and observe a very clear parabola. And you can imagine we could move that plane around and get slightly different kinds of parabolas. We know the graph of a quadratic function is a parabola. A quadratic function is f of x equals ax squared plus bx plus c, as long as a does not equal 0. But we can also define a parabola geometrically as the set of all points in a plane, equidistant, meaning the same distance from a fixed line called the directrix, and a fixed point not on the line called the focus. Let's consider what the geometric definition of the parabola means. So here's my focus up here, and down here is my line, the directrix, and I have a point here on the directrix here, and a focus, and there's a line of equal length joining the focus to a point on the parabola and the point on the parabola to a point on the directrix, or the line. Notice they're the same length. That's what those little equal signs mean. Now, if I put blue ink on this point, and it would draw out the parabola as I move it around. But importantly, as I move this around, this length, the length from the focus to the point on the parabola, and this length, the length from the directrix to the point on the parabola, remain the same. Even though they change, they're always equal to one another. It's as if I have a very, very elastic piece of string, and as I draw out the parabola, it shrinks and expands, but in both cases they are always of equal length. The standard equation of a parabola with a vertex at the origin, point 0, 0, and a directrix y equals minus p is x squared equals 4yp. The focus is the point 0, p. The y-axis is the axis of symmetry, and the parabola will open up if p is greater than 0, and it will open down if p is less than 0. So if we work on this example, we were asked to find the directrix, that line, and the focus, the point, for the parabola y equals 1/8 x squared. So my standard equation, I'll just write that as STD for standard, and that's going to equal x squared equals 4yp. I want to write this in the same form. So in a new form, then I want y equals, and I'm going to have to divide both sides by 4p. So it's going to give me 1 divided by 4p x squared, and then it has the same format as my given equation, and then I can equate the different components. So I can equate the parts that line up, if you like. So that means that 1 divided by 4p is equal to 1/8, and of course that's the same as 4p equals 8, and so p is equal to 2. So the directrix, the line that I'm asked to find, well, that's going to equal y equals minus p, which is -2, and the focus, which is the point, that's 0p, so that is 0, 2. And we can see our graph. And here's the directrix with the line equals y equals -2 and the focus at 0, 2. And you can clearly see the axis of symmetry, that is the y-axis. If the parabola does not have a vertex at the origin, if it has a vertex instead at the point hk, then the standard equation is the quantity x minus h squared equals 4p times the quantity y minus k. The directrix is y equals k minus p. The focus is the point h, k minus p. And it still has a vertical axis of symmetry. It still opens up if p is greater than 0 and down if p is less than 0. And so let's move on and work our example. In the example, we're asked to find the vertex, the directrix, and the focus for the parabola. And here we've got x squared minus 2x equals 2y plus 5 equals 0. And we want to try and rewrite this equation so it looks in the standard form. So I have x squared minus 2x equals negative 2y subtract 5, and I'll have to complete the square. Completing the square for the x term, so I've got negative 2. I've got to divide that by 2 because I always divide the coefficient of the x term. That's going to give me negative 1 squared. Of course, that's just 1, so that's what I add to both sides. So I have x squared minus 2x plus 1 is equal to minus 2y minus 4 after I complete the square. And if I rewrite this, I have x minus 1 all squared is equal to negative 2 times y plus 2. And this is pretty similar to my equation up here, my standard equation. If I equate components, then I'm going to get h is equal to 1, k is equal to negative 2, and now I'll have to look at my original equation and I see that 4p is equal to negative 2, so p is equal to negative 1/2, and now I'm prepared to answer the question. So after we've completed the square and we've solved for h, k, and p, we can see that the vertex, in this case because it opens down, it's the maximum value or the maximum point, and that's going to be 1, negative 2. The directrix is a line, and that's going to be y is equal to k minus p, so y equals minus 3/2, and the focus is going to be the point h, k plus p, so h is 1 and k plus p is minus 5/2, and we can see our parabola in the graph below. One of the advantages to using conics for our equations is we can consider left and right parabolas. So the standard equation of a parabola with vertex hk and directrix x equals h minus p is the quantity y minus k all squared equals 4p times x minus h. The focus now is h plus pk, and this has a horizontal axis of symmetry. P is positive, the parabola opens right, and if p is negative, the parabola opens left. In our example, we want to find the vertex, the directrix, and the focus for the parabola y minus 5 all squared equals negative 8x plus 4, and I can pretty clearly see it's going to open to the left because it's negative in front of that x. And this is an equation that's already in the standard format, so I'm going to be able to just read off a lot of these values. Y minus 5 tells me that k is equal to positive 5. X plus 4 tells me that h is equal to negative 4. And now what I can do is I can line up 4p and set that equal to negative 8. And that tells me very quickly, of course, that p is negative 2. So now that I have all of these values, I can answer the question. The vertex will be the point hk, so make sure you don't mix that up. Minus 4, 5 is the vertex. And the focus, well, I can just look at my formula and read off the point that is the focus. So that's going to be h plus p, k, and h is negative 4 plus p is negative 2, so that's going to give me negative 6. K, of course, is 5. So the focus is the point, negative 6, 5. Now I want to write the directrix. And the directrix is going to be x equals h minus p. And that is x equals negative 4. And that's going to be a subtract. Just ignore that context-sensitive menu there. That's going to give me x equals minus 4 plus 2, because it's a negative negative. So x is negative 2 is the directrix. So we can clearly see this is a left opening parabola. We can see the vertex there. The rightmost point is negative 4, 5, the focus, and the directrix as shown. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.